AI automation is pretty much everywhere these days, from our phones to our factories. And it can seriously feel like magic, right? But it's not. Behind every one of these smart systems, there's a really structured, rigorous engineering discipline. It's what we can call an AI factory. Okay, so let's peel back the curtain and see how this factory actually works.
To really wrap our heads around this, you gotta understand this one fundamental shift. On one side, you've got traditional automation. It's basically just a giant list of rigid, pre-programmed rules. If this happens, then do that. It works, for sure, but it's brittle. The second something unexpected happens, the whole thing can just break. But on the other hand, you have AI automation. This stuff is adaptive. It doesn't just follow a script. It learns patterns from tons and tons of data, which lets it handle all the messy, ambiguous stuff in the real world.
So, what's the engine driving this new way of doing things? Well, it's something called machine learning. And here's the key takeaway. Instead of a programmer trying to write thousands of lines of code for every possible scenario, we just show the machine millions of examples. And from all that data, it discovers the underlying patterns and figures out the rules all by itself. It actually learns instead of just obeying.
Right, so how do you actually build one of these learning systems? It's not some single eureka moment. It's much more like an assembly line, a repeatable industrial process. So, welcome to the 5-step AI factory, where we're going to build intelligence right from the ground up.
Okay, here's our roadmap. It all starts with gathering and cleaning data. Then we use that data to train the model. After that, we connect it to the real world, let it do its thing, and finally, we keep an eye on it and retrain it to make sure it stays on top of its game. Let's break down each of these steps.
Step 1, and you absolutely cannot skip this, it all starts with data. This is the foundation for everything, and you've probably heard the saying, garbage in, garbage out. Well, nowhere is that more true than right here. This step, just gathering massive amounts of data, cleaning it up and labeling it so the AI knows what it's looking at, is honestly often the most difficult and time-consuming part of the whole process.
And when I say vast, the scale is kind of hard to even picture. We're talking petabytes of data. For a little perspective, a single petabyte is the same amount of data as thousands and thousands of high-definition movies. And complex systems like self-driving cars need that much info, or even more, just to get started.
All right, step 2, training. This is where it really feels like the magic starts to happen. We feed all of that data into a model, which is often a neural network, sort of like a digital brain. It makes a guess, checks its work to see how wrong it was, and then tweaks itself just a tiny bit to be a little less wrong next time. Now imagine repeating that process millions or even billions of times. What you get at the end is a system that can see incredibly complex patterns.
But here's the thing. A perfectly trained model is, well, it's pretty useless on its own. It's basically a brain in a jar. Step 3, deployment, is the massive engineering challenge of giving that brain a body, hooking it up to live systems and sensors so it can actually see what's happening in the real world and take action.
And now we get to the payoff. This is the moment the AI flips the switch from learning to doing. It's called inference. The system takes in live data, stuff it has never, ever seen before, and in just milliseconds, it makes a prediction. This is all that training put into action right when it matters.
But wait, we're not done yet. You can't just set it and forget it. The world is always changing, right? So the AI has to change with it. This last step is really a continuous loop. You have to watch how the model is performing, feed it new data from the real world, and constantly retrain it to make sure it stays accurate and adaptive over time.
Now, that whole 5-step process, it brings up a really, really important question. If an AI learns from experience, how on earth do you let it experience things that are incredibly dangerous or just super rare? Well, let's look at the answer. The AI's secret sandbox.
I mean, think about it. You can't have a self-driving car learn by, actually crashing a few hundred times. That's a terrible idea. And you can't just shut down a power grid to see if your AI can handle a blackout. So what do? How do you possibly train for these critical high-stakes situations?
The answer is simulation. We build an ultra-realistic virtual world, a digital twin of the real one. And inside this digital sandbox, the AI can experience millions of different scenarios. It can fail thousands of times, and it can learn from every single mistake, all with absolutely zero real-world cost or consequence.
So, simulation is a total game changer, and it plays 3 crucial roles for us. First, it can generate endless amounts of perfect synthetic data for training.
Second, it acts as a playground where the AI can just learn through pure trial and error. And finally, it's the ultimate validation tool. It lets us stress test the AI against every bizarre, one-in-a-million scenario we can think of before it ever gets near the real world.
So when you put this whole factory process together with this super safe sandbox, what does that look like out in the real world? Well, you get this fascinating mix of incredible results and some really tough paradoxical challenges.
And the payoff is already huge. In factories, AI can predict when a machine is about to fail, saving companies millions in downtime. In hospitals, AI algorithms are helping doctors spot potential tumors on medical scans much earlier. And in warehouses, you have autonomous robots navigating the floor, optimizing routes in real time, 24/7. The impact is just massive.
But, and this is a big but, all this power comes with some serious challenges. First up is bias. If the data we feed the AI has our own human biases baked into it, which it almost always does, the AI will learn those biases and can even amplify them. Then there's the black box problem. Sometimes these systems get so complex that it's nearly impossible to understand why they made a certain decision. And finally, there's the huge energy cost. Training these massive models consumes a staggering amount of power, and that has a very real environmental impact.
So where does all this leave us? Look, understanding this whole factory, the data, the training, the simulation, it's not just for engineers and data scientists anymore. As these systems quietly start to shape our entire world, knowing how they actually work isn't a technical curiosity. It's becoming a civic necessity for all of us. The silent revolution is already here, and now you know how its engine really runs.